In this video, we're talking about exponential functions, and again, we're kind of focusing on the idea of a parent exponential function and how do we transform it into a child exponential function. So the graph of the parent exponential function is given by the graph, or by the function y equals a times b to the x power, where b is called the base. The parent function has a couple properties. It always is going to pass through the point 0, a, so it's important we know what a is. And the x-axis is always an asymptote of the graph. So when you think of asymptote, that's just kind of like a force field. The graph is going to get really close to the x-axis, but it's never really going to touch it. Okay, and the transform graph of the child exponential function is given by y equals a times b to the x minus h power, then plus k. To graph this function, again, all we're going to do is start off by graphing the parent function, and then we're going to shift the graph h units horizontally and k units vertically. So very similar to what we just did with the radical function. In example 22, I had the child function, y equals 3 times 2 to the x minus 1 power, minus 4, and we also want to state the domain and range. So here, the parent function is given by the dotted blue line, and the transformed child function is given by the solid blue line. So what I want to do is start off by listing what a, h, and k are, just like I did in the previous video, and then we'll talk about the domain and range. So here, based on our pattern that we were given, a is 3, h is 1, and k is minus 4. Remember, we always start off with the parent exponential function, and it always goes through the point 0, 3, since a is 3 in this case, and that checks out. Then to get to the child function, we're shifting horizontally 1 unit and down vertically 4 units. Oh, and I get to my child function, and that happens anywhere I have a point on my parent function on this particular graph. Okay? Let's talk about the domain and range. Let's start off with the domain. Again, for our purposes, we're going to think of the domain as x values. So when I'm looking at the domain, all I'm thinking about is how does the graph behave as I go to the left and go to the right? Are there any restrictions on the graph in those two directions? Well, as I go to the left of my child function, I can see that it keeps going all the way to the left as far as it wants. There's no stopping it. As I go to the right of the graph, I can see that the graph is very gradually going, but it is still going to the right as far as it wants to go. So the domain for the child function here is all real numbers. Now let's talk about the range. Well, remember with the parent function, we said that it has an asymptote as the x-axis, but now we've shifted that asymptote down 4 units. So no matter what we do, we're going to have an asymptote that the graph is going to get close to but never touch at y equals negative 4. That's for the child function, okay? So the graph is going to get close to that but never touch it. So that asymptote is going to restrict our domain. So the graph can get as close to y equals negative 4 as it wants to, but it's never touching negative 4. And then obviously the child function is going up, 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 up. It's an exponential function, so it goes to positive infinity very quickly. So our range, we're going to say y is greater than negative 4. Not greater than or equal to. Again, asymptote, it never touches. So y is greater than negative 4. It can get to negative 3.9999999 repeating, but never get to negative 4. So that's the domain and range for this particular exponential function. You might have noticed that since the parent asymptote is always the x-axis, the child asymptote is always whatever our vertical shift is. Since in this case it was negative 4, our asymptote's at negative 4. If this was at a positive 8, then our asymptote would be at positive 8. So just pay attention to your vertical shift to find your asymptote. And your asymptote is always going to be y equals a number. Let me know if you got any questions. That's it for this video.